Now I'm expecting this video to be one of the least ever watched, but perhaps one of the oddly more useful videos. With part D of this question, doing a model solution of it, I got it completely wrong the first time. Now if you want the correct solution, there's another video with everything on this question, the whole lot, one at a time and with the correct solutions. But it's often quite helpful to see an incorrect answer. Firstly, you can see the sort of thought processes you go through. You can see the things that will eventually lead you to the correct answer. And secondly, if you're sitting there feeling terrible about the fact that these are horrible questions and it takes you ages to get them right sometimes, well, you know, that still can happen to me. You know, I've been a maths teacher for a good number of years. I've done these questions a lot of times, and still sometimes you just don't see the right way. There's nothing wrong with that. And sometimes it's helpful to see how to get it wrong in hopefully a productive manner, because if you look at the correct version of this question that I've done on the other video, I worked out how to do it by getting it wrong. So here is the incorrect version for anybody that's interested. And once I've finished getting it wrong and realised that I can't get any further, this video just stops. Looks quite nasty, but often looking quite nasty is to our advantage, because there's an awful lot we can do with it. So as I'm writing it down, I'm thinking cot, that is cos over sine. Cosec is 1 over sine, so cos over sine, cos over sine on the top, something over sine on the bottom. So if I simplified the denominator, then I'd have a fraction on the top and a fraction on the bottom, and the sine would be the denominator of the fraction on the top, sine would be the denominator of the fraction on the bottom, and maybe they'd cancel out. I'm maybe not even going to do that, but it's going through my head as I just copy it out. I've got a cos x here and a sine x here. So I've now got 4 different trig identities involved, which seems a bit of a pain, and I'm aiming for 2 times tan x. So tan x, that's something to do with coses and sines, isn't it? So I'm thinking maybe if I could do get the left hand side just in terms of cos and sine, that would help. What else am I thinking? Well, in that case, getting rid of the cot and the cosec might be good. I can't see anything about this fraction that tells me anything clever about how to cancel it out. The only thing that I might think of is that the bottom of this fraction is something minus 1. This one is 1 plus something. And do you remember that trick from when we were rationalising denominators? If you had something like 1 minus root 2, you times the top and the bottom by 1 plus root 2. And 1 plus, you know, we use a difference of 2 squares trick. Now these aren't differences of 2 squares, but you know, they look like half of a difference of 2 squares each, so maybe there's something in that, but it's grasping at straws really. So I think the only thing I've got is to take this fraction here, and I'm going to write it as cos x over sine x divided by 1 over sine x minus 1, which is cos x over sine x divided by 1 minus sine squared all over sine x. So this fraction here turns into this, and the sine x's are going to cancel out, or if you want to, you can do keep flip change on this. So either way, we end up with this cos x over 1 minus sine x. And then this thing has just been the same all the way down, so I'll just copy that down to here. Cos x over 1 plus sine x. Sorry, 1 minus sine squared there, isn't it? Now, 1 minus sine squared is a cos squared, isn't it? So here I've got 2 possibilities, and I'm going to make a mental note of both of them, because the one that I choose might or might not be correct. 1 minus sine squared is a difference of 2 squares. So we get 1 minus sine, 1 plus sine. So I could, and then I could add together these 2 fractions, couldn't I? So that's one thing I could do, is I could factorise that, and I notice that this factor here is the same as this factor here, so maybe that would help me. The other thing that I could do is write this as cos over cos squared, so this becomes 1 over cos, and then add the fractions together. I don't know which of those is going to work. I'm going to go for the second one. As I do that, I'm just still looking at it, thinking, well, is it sensible to go for the second one? Is there anything that I can see that would hint that this is a better way forward? Maybe there is. Maybe you can see it and I can't. But I can't see it, so I'm going this way. I've just decided that I think that will work, so I'm going to just keep that in my memory for later if this fails. So what have I got? 1 minus cos squared over, hang on a sec, let's do that a bit more carefully, times this fraction by 1 plus sine on the top and bottom. 1 plus sine x over cos x brackets 1 plus sine x times this fraction by cos on the top and the bottom plus cos squared x on the top and bottom there. And this is looking a bit of a mess to me. Let's see, cos squared x plus 1 plus sine x over cos x brackets 1 plus sine x. I've got a little bit of hope here. Cos squared is 1 minus sine squared. I think it's going to work. Sorry, missed out a plus 1 there, didn't I? So what I've got on the top is, let's go up here. What I've got on the top is sine squared x plus sine x. Sorry, minus sine squared x. Yeah, minus sine squared x plus sine x plus 2 over cos x 1 plus sine x. So the top should factorize into, let's see, minus sine x plus 1 is sine x plus 1. This is not helping, is it? Minus sine squared minus sine, yeah, okay. So we've made a mistake somewhere, or at least it's not helping. So what I'll do is we'll go back to this plan and see if that works for us. Now, the thinking here is cos x minus cos x 1 minus sine x over 1 minus sine x 1 plus sine x. So where does that leave us? We can factorise the cos x out of the top. And I get this. I'm going to turn the bottom back into 1 minus sine squared, and I'm going to turn it into a cos squared. The cos cancels with the cos squared, and I end up with 1 minus 1 plus sine x. So I end up with sine x over cos x, which is tan x. Oh, and I was aiming for 2 tan x. So there's a mistake in there somewhere. Ah, what a pain. Right.